Hi there, thank you for joining us. This is the proportions video. In this video, I will teach you to solve proportion problems. We will take a look at the equation to use, review the steps to solving with the equation, and practice with some word problems. Okay, let's get started. So proportion questions can take many shapes or forms, but all proportion questions can be solved with one equation. First, let's look at the equation you should use to solve the proportion problems. Proportion questions make comparisons between two different scenarios. These scenarios are basically comparing ratios, so it's important for you to learn how to identify a proportion question. Proportion questions compare two scenarios to each other, meaning the ratios are equal to each other. I hope that makes sense. We'll look at some questions and hopefully it'll help to move the idea along a little bit better. Okay, so the equation that we're going to use for proportion questions is really simple. It's a lot like the percentage equation. Essentially what you're doing is comparing one fraction to the other because you're saying that the ratio in this fraction is equal to or proportional to the ratio of this fraction. So I know this looks funny because it's apples to oranges, but I promise I'm going to prove a point. But what I want you to understand first is that scenario 1 is being compared to scenario 2. And the reason these questions are called proportion questions is because this ratio or this fraction is proportional or equal to the other one. So that's how we can compare these two scenarios. I hope that makes sense. So the next thing I want you to understand, and the reason I have the apples and oranges for you, is that the top and the top have to be the same, and the bottom and the bottom have to be the same. So if we're comparing buckets, it has to be buckets to buckets. So the buckets in scenario 1 have to be in the same position in the equation as the buckets in scenario 2. Or the apples in scenario 1 have to be in the same place as the apples in scenario 2. Same thing goes with the bottom, okay? So if we misplace them and we don't put them in the right place in the top and the bottom, we are more than likely not going to get the right answer. So one more time to make sure you understand, scenario 1 is the first fraction, scenario 2 is the second fraction. We're comparing these two and saying that their ratio is proportional or equal to each other. And we have to make sure that these things match, okay? We also have to make sure if we're working with units that the units are the same. All right, so let's go ahead and take a look at some questions to make sure you understand how to put this into practice. I promise once you start using it, it's gonna make a lot more sense. All right, let's go. So let's go ahead and look at some examples. A photograph is 4 inches wide and 6 inches long, and it is enlarged so that it is 6 inches wide. What is the length of the enlarged photograph? Go ahead and try it on your own, and then I'll come back and work it out with you. All right, welcome back. How'd it go? I hope you got it. If you didn't, don't panic. I'm going to go over the question with you now. Let's go ahead and take a look at the givens. Remember, we start with the givens, we understand what the question is asking us for, and then we solve. So the givens basically say that one picture is 4 inches wide, the other one is 6 inches long. So that's going to be our scenario 1. Let's set it up. 4 inches wide. Now I like to write everything out because I want to make sure that I'm putting everything in the right place and I don't want to get confused. Especially with this question that everything is in inches. So it can be a little confusing like that. So this is the width and we're comparing it to 6 inches in length. All right, let's put this here. So we're saying that this ratio or this proportion is proportional or equal to our scenario 2. Well, what is scenario 2? Scenario 2 would be the enlarged photo. Now, what do we know about the enlarged photo? We know that the width of the enlarged photo is 6 inches. So let's put that up here because we put the width of the photo up here. So that means we have to put the width of the second photo up here. So 6 inches wide. And do we know the length? No, we do not. So we're going to call that x. All right? So let's go ahead and cross multiply. Whenever we have two fractions equal to each other, we can always cross multiply, no matter what the scenario is. If there's nothing else multiplied to them or added to them, and these things are aside, they have an equal sign in the middle, just cross multiply them. So 4 times x is 4x, and 6 times 6 is 36. Easy, right? So now we have to solve for x. We do that by dividing by 4, and we get x equals 9. So that means that the length of the enlarged photo is 9 inches. All right, I hope that makes sense. If you didn't get it, go over it again and make sure you understand. If you do, then let's move on to the next question. The question says, it takes 4 buckets of water to wash 3 windows. If a building has 8 windows, how many buckets of water will be needed to wash all of the building's windows? All right, go ahead and give the question a try, and then I'll work it out with you. All right, welcome back. How'd it go? I hope you got it. I'm sure you did great. If not, don't panic. We're going to go over it together now. So remember, we start out with givens, then we look at the question, and then we solve it. All right? So the givens are for this question. 4 buckets of water to 3 windows. That's scenario 1. 4 buckets, 3 windows. All right? The second scenario is unknown buckets. That's what the question is asking us for, and 8 windows. All right, so let's put it in our equation and let's see how to work it out. So we have 4 buckets for every 3 windows. As you can see from this question, proportion equations can be used for almost anything, right? So that's scenario 1. Scenario 2, we have no idea how many buckets we need, so we're going to call that x. So x goes up here, but we do know that we are going to wash 8 windows with these buckets. So we're going to set it up in the bottom. Windows and windows are the same. There are denominators, and buckets, when we solve for this x, that means we're solving for buckets. Got it? All right, let's cross multiply because that's what we can do every single time we have one of these questions, when we have a fraction with an equal sign and another fraction. So 3 times x is 3x. 4 times 8 is 32. We're going to divide by 3 because we want to isolate the x. 32 divided by 3, is not an even division. So we're just going to work it out and try to get it to maybe like one number behind the decimal point. So 3 into 32. 3 goes into 3 one time. Sorry, that's a 0. We bring down the 2. 3 goes into 2 0 times. We can add a 0 and bring it down. But if we do that, remember we have to put a decimal point up here, okay? 3 goes into 20. Oh, sorry about that. 6 times. 3 goes into 26 times. 3 times 6 is 18. 20 minus 18 is 2. So we have 10.6, and we're going to stop there because if not, it's going to get a little complicated. The question is asking us for buckets. Now, when you get buckets of water, do you get 10.6 buckets of water? No, you'll get 11 buckets. So we're going to round that up to the next one. So we can answer this question by saying 11 buckets of water. All right, I hope that made sense to you. If not, go over the steps again. Take your time, make sure you understand before moving on to the next one. If you got it, then let's go ahead and keep practicing together. Let's go ahead and do another question. A recipe calls for 2 cups of water for every 1.5 cups of flour used. If Sarah only has 2.5 cups of flour, how many cups of water will she need? Go ahead and give it a try, and we'll work it out together. How did the question go? Did you get it? I hope you did. I hope it's making a little more sense. If not, don't worry about it. We're going to go over it step by step. So let's remember, we start off with givens. So let's go ahead and look at the givens together. So scenario 1 is 1.5 cups of flour for every 2 cups of water. Okay, so we're going to put that in a fraction as scenario 1. So 2 cups of water. Because all of this is in cups, I'm going to go ahead and write what the cups are of so we don't get confused. So 2 cups of water for every 1.5 cup of flour. Okay, so we're going to put that here. This is scenario 1. This is our recipe. Now, scenario 2 would be what we actually have, or what Sarah actually has. So she has 2.5 cups of flour. And notice we put this in the bottom. We put this in the bottom because we know that in scenario 1, we put the flour in the bottom. So in scenario 2, we have to put the flour in the bottom as well. So the question is asking us for how much water she will need. We know that's our unknown. It's the only given that we don't have. So we're going to call this x. So we cross multiply because that's just what we do when we have 2 fractions equal to each other. 1.5 times x is 1.5x. Now we're going to set that equal to 2 times 2.5, which is 5. We're going to divide by 1.5 to isolate the x, and we're going to go ahead and work this out. So to be able to divide when you have a decimal out here in the divisor, what you have to do is you have to move this decimal. You can't have one. You have to get rid of it. In a whole number, essentially a decimal is at the end of the number. So we have to move the decimal 1 over to the right the same way we did outside, okay? Which means we add a 0. So 15 into 50, that's what our problem turns into. 15 goes into 50 3 times. 15 times 3 is 45. 45 minus 5, 50 minus 45 is 5. Now we can go ahead and annex a 0 and bring it down. Remember, we would add the decimal up here as well because we added a decimal in the bottom. 15 goes into 50 again 3 times. You'll notice that this is a repeating one, so we're not going to keep going and making this more complicated. We're going to leave it here. So we know that she's going to need approximately 3.3 cups of water. And that's it. We solved the problem. So I hope this made sense to you. If it didn't, go ahead and watch it again and go through the steps. Look to see what you did wrong maybe when you did it if you got it wrong. If you get it, then great. Let's go ahead and move on to the next question. 6-foot man is standing next to a tree. The man's shadow is 8 feet long and the tree's shadow is 20 feet long. If the length of the shadow is proportional to the height of the subject, what is the height of the tree? All right, give it a try. All right, welcome back. How'd it go? I hope you got it. This one is a little complicated, so don't worry if you didn't. We're gonna go ahead and work out that problem together. All right, here we go. So scenario 1 gives us a 6-foot tall man next to a tree. We don't know how tall the tree is, all right? But we know that his height is 6 feet and that the tree's height will be X feet. We don't know how much it is, so we're gonna call it X. So we're gonna make that scenario 1. 6 over x, because that's our actual. We're going to do scenarios as actual and shadow, okay? So I'm going to put that up here so it's easy for us to remember. Actual versus shadow. So we know that the man is 6 feet tall, but we don't know how tall the tree is. But we do know their shadows, right? And their shadows are 8 feet for the man and 20 feet for the tree. So far, so good? Scenario 1 is the actual height. Scenario 2 is the shadow height. All right, so let's go ahead and cross multiply. 6 times 20 is 120, and that's equal to 8x because 8 times x is 8x. We're going to divide by 8 so that we can go ahead and isolate the x and solve. And let's set that up over here. 8 goes into 12 one time. 12 minus 8 is 4. We bring down that 0. 8 goes into 45 times. 8 times 5 is 40. 40 minus 40 is 0. So the tree is 15 feet tall. Okay? I hope that made sense. What made that a little complicated was actually setting up the scenarios, but I'm sure you got it. If you didn't, go back and go step by step, see where you messed up and how you can improve for the next one. If you got it, let's move on to the next question. A map has a key that indicates that every 1.5 inches on the map is equal to 200 miles. If Brownsville is 2.5 inches away from Greensville on the map, how many miles apart are the towns? Go ahead and give it a try. All right, welcome back. This is the last question, so I hope you made it count. Let's go ahead and look at the givens together. So we know that scenario 1 is 1.5 inches on the map. That's the distance of the map to 200 miles, which is the actual distance, right? And we're comparing the distance, we're comparing the scenario to the distance between two towns on a map. So let's set up scenario 1 as our key, all right? So scenario 1, we have 1.5 inches is to 200 miles. Scenario 2 gives us the inches and then asks us for the miles. If you look at the question, it says how many miles apart are the towns. So 2.5 inches on the key and x miles, because this is our unknown and it's what we're looking for in our question. So let's go ahead and multiply stuff. So 1.5 times x is 1.5x. 200 times 2.5, we know that 2 times 2.5 is 5, and then we have 2 zeros, so 500. Then we divide by 1.5 so we can isolate the x, and we set that up in a division problem right here. Now we've gone over this before. Remember I told you when we have a decimal on the outside, we can't have that. We don't want it there. So we have to move that decimal point over 1. And because this is a whole number, we're going to move it over 1 here and fill that gap in with a 0. So this question is rewritten as 15 into 5,000. So 15 goes into 50 3 times. 15 times 3 is 45. 50 minus 45 is 5. Bring down the 0. 15 goes into 50 3 times. 15 times 3 is 45. 50 minus 45 is 5. And we bring down the other 0. I know it feels like we're doing this a lot, but we have to make sure we use up all the zeros before we stop, because if we don't, we won't get the right answer. So 15 goes into 50 again 3 times. So 15 times 3 is 45. 50 minus 45 is 5. So we know that the distance between the two towns is 333 miles. All right, I hope that made sense. If not, go back. You know how we do it. We go back, we check, we look at our steps and see where we went wrong, okay? Good luck. I hope you found those problems helpful. If you didn't understand any of the steps, make sure to watch the video again or contact us for any additional help. Remember to practice and use all of the resources available to you. Practice, 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 practice. Practicing will get you the score you want. Thank you for watching and good luck.